Here's another trigonometric example. Just like in our previous example, we're going to need to square both sides. And it's going to be almost exactly the same, except that now we're dealing with tangent and secant. So if we square both sides, we're going to end up with x squared equals, and then that's going to be 25 times tangent squared. And if we square the other one, now it's going to be y squared equals, and then if you square that side, that's going to be 9 times the secant squared. And it's 9 because we're squaring 3. 3 times itself is 9. So 9 secant squared equals t. So in the previous example, we had the functions by themselves. So we're going to do the same thing here. We're going to divide both sides by 25. The 25s cancel out, and now we just have tangent squared by itself. We do the same thing on the other one, divide both sides by 9, and now we have the secant squared by itself. So what identity could we use here? Remember that secant squared minus tangent squared is equal to 1. So we'll need to subtract these. So let's write the first one just so we have everything all together. So x squared is the same as x squared over 25 is the same as tangent squared t. And then on the other one, y squared over 9 is the same as our secant squared. So again, remember the identity. The identity says that we need to subtract those things. So secant comes first. So because secant squared is the same as y squared over 9, here's what we're going to do. We're going to put that first. So we're going to say y squared over 9, because that's our secant squared, and that comes first. And that's going to be minus the second part, which is our tangent part. Remember, tangent comes second. So it's going to be x squared over 25. So what happens in our equation again when we subtract secant squared minus tangent squared? And basically we know we have to do that because that's what we're subtracting. We're subtracting our secant squared part of our equation minus the tangent squared. So we're going to say secant squared, and I know I put x, but it was really t. But in any case, it's the same thing. It's going to end up being the same problem. Whether it's t, x, y, z, theta, secant squared minus tangent squared will always be 1. So now this whole thing is equal to 1, and we're done.